In this episode, we're going to be looking at what constitutes as a chemical reaction versus something that is simply a physical reaction. Words such as burn, rot, rust, decompose, ferment, explode, one of my favorites, and corrode are usually chemical changes. So the ability to undergo this chemical change is called a chemical property. So for example, when charcoal, that stuff that you put in the grill, is heated and burned, a chemical change is occurring. You can tell by the change in color that it has, as well as the ability to produce heat as it is undergoing this change. And what occurs is charcoal is going to react with oxygen in the air to form other substances. Anytime that one or more substances changes into a new substance, this constitutes a chemical reaction. Whereas if you were to simply break that same charcoal we saw on the last slide into smaller pieces, that is a physical change. Remember, break is one of the words that is for an irreversible physical change. The substance present before the change is still present after the physical change, although the pieces are a little smaller. So chemical change is also called a chemical reaction, and it's an interchangeable word. I'll probably say chemical reaction more often. The substances that you start out with are called the reactants, and the ones that you make or produce are called the products. There are some clues that are going to give you hints that a chemical change has occurred, but you can never be certain just based on your observation. Instead, you have to actually test the chemical makeup of a sample before you start the experiment as well as after. That way you are positive you have undergone a chemical change. So for every chemical change, there are a few clues that you might be able to see that help you recognize that a chemical change is occurring. The first one is that there is a transfer of heat. Oftentimes this is accompanied by light as well. So you use this most often whenever you go to cook food. If you have a gas stove, there's methane that runs through your house and up to your stove, and it's going to be combined with oxygen in the air as well as a spark. That's the little click that is in your stove whenever you turn it on. From there, energy is definitely given off. You don't want to put your hand on it because that energy is very, very hot. It also is in the form of light. That energy is then transferred and absorbed to your food, so you're able to cook your food until you want it to be finished, I guess. So your energy is going to cause this chemical change to take place. A second clue that you would definitely want to make sure that you note of is the production of gas. On the right here you see an Alka-Seltzer tablet. And what it's doing is creating bubbles when it reacts with water. That carbon dioxide, that release of carbon dioxide shows that the Alka-Seltzer tablets are reacting with that water. Again, these are only clues you have to test to be certain. The third way to see if there is some sort of chemical change is that there is a color change. Sometimes this could be as simple as you dip a test strip into a solution like the one shown, or it could be something as different as going from a clear solution to a bright red solution, all of which indicate that you are undergoing a color change or a chemical change. Finally, your fourth and final clue is the formation of a precipitate. And that simply means that when your chemical reaction is occurring, you get some sort of solid at the bottom of your beaker. And you can see this in the production of cheese. There's a reaction that causes milk to separate and become solid. that solidity is what the chemical change is in. So let's put these clues into action. Whenever you are burning a match, is this a chemical or a physical change? And how do you know? Well, let's think about it. Whenever you have something that is burning, there's a lot of energy being released, and that is a great indicator of a chemical change. There's also a color change, right? So before, the match was this light white color, whereas after it is this dark black color. Whenever you burn that match, you start to notice that it starts to get a lot smaller. A great example is if you build a campfire. You start with gigantic logs, and by the end you have a small pile of ashes. And what seems to occur is that there's a reduction in matter, but that isn't the case. Whenever you are burning wood, carbon dioxide gas and water vapor are actually released into the air from the wood. That accounts for the mass that appears to be lost. After some careful measurements, the total amount of the total mass of the reactants equals the total mass of the products. This is true for both physical and chemical changes. For example, if you were to take 10 grams of ice and melt it, you would get 10 grams of liquid water produced. This is true because of the law of conservation of mass. This states that in any physical or chemical reaction, mass is always conserved. It cannot be created nor destroyed. The best way to actually observe this is whenever you are having a closed container without any gas that can escape. This is because gas is really difficult to catch and quantify, but whenever you are starting with two reactants here on the left, you see that they start with 43 grams and it ends with 43 grams. This is because the mass must be conserved. Otherwise, you may have lost some mass to gas. As always, here are some of the vocab words at the end of the PowerPoint. Hopefully, you have taken note of the clues to chemical reactions, and we'll talk about these more tomorrow.